Food safety experts recommend cooking beef to at least 140 degrees Fahrenheit and chilling leftovers immediately to below 45 degrees Fahrenheit. The table shows approximate amounts of bacteria in a sample of beef at room temperature to demonstrate the danger of leaving meat at room temperature. Use constant ratios to generate an exponential function model. Then compare the domain and range of the function model to the domain and range of the dataset. Okay, so first let's just look at our two quantities here. So we've got the time that the beef is at room temperature, and so that just goes in order there. So time is most of the time independent, and here that will be the case. So we can just call that T for time, and then we have the estimated number of bacteria in the sample, and so that's dependent on our time. So that will be our dependent variable, and we can just call that B for bacteria of T. And then to actually find the model, then remember that our general form for exponentials is f of x equals a times b to the kx for just our real life situation exponential functions. And so in our case, of course, it won't be f of x, it'll be b of t, and then a is the starting point when the independent variable is 0. So when t equals 0, then b of t is 10. So a will just be equal to 10, and then b is the constant ratio. And so to get that, then we'll just take the y value of the larger x and divide it by the y value of the smaller x, and going in order. And since each delta t here is just 1, that's important. We do need a constant delta t here, and so it is 1 each time. So we can go ahead and now just divide. So we'll take 2,621,440 and divide it by 327,680. And so we get 8 dividing those two. And then dividing the next two, so dividing 327,680 by 40,960, we also get 8. And same with the next ones, we actually get 8 dividing out every single one. And so we get that b is equal to 8. And then since our delta t is just 1, then that would be influencing our k value. So the k really won't influence here. And so then we'll just have x, which in our case is t, the independent variable. And so then there's our function. So let's go ahead and compare the domain and range of the function versus the data set. And so for an exponential function, the domain is just going to be all real numbers, since we can plug in anything for that exponent. So it'll be the set of t's such that t is a member of the real numbers. And then for the range, then we know that it'll be the set of b of t such that b of t, and then with exponentials, if there's nothing added or subtracted separate from the exponential term, and also there's no negative, which would flip our exponential down to make it negative, so we know then that b of t will just be greater than 0. And the data set is actually very specific. So for the t values, we just have 0 through 6, and those are just whole numbers. So we can say the set of t such that t is a member of the whole numbers, and then it's only between 0 and 6, and so we can write this as 0 is less than or equal to t is less than or equal to 6. And then for the range, then we know it's going to again be the set of b of t such that, and then here, b of t, they are also whole numbers, but they're just specific points within the whole numbers, and so we can just go ahead and write what those specific points that b of t is equal to. So it would be 10, 80, 640, and so on. And so now that we have our domain and ranges, we can see that the data set is just a small subset of the numbers of the domain and range of the function model. And so the function model has infinitely more values in it. And so now that we've gone ahead and answered these questions, let's go ahead and summarize. Let T represent the time in hours that a beef sample has been at room temperature, and B of T represent the number of bacteria in the sample of beef. Using successive ratios, the modeling function is B of T equals 10 times 8 to the T. Then we have our table with our domain range for our function and the data set. Since b of t is an exponential function, its domain is all real numbers, and its range is all real numbers greater than 0. The data set, however, has a domain that is a specific subset of whole numbers, and a range that is a specific subset of whole numbers. Infinitely more data points are contained in the domain and range of the function model b of t than in the finite data set.